I want you to think about, I mean, really specifically think about exactly what you were doing maybe 3 minutes before you hit play on this audio.
Right. Just put yourself right back in that exact moment.
Yeah. Like, were you maybe scrolling through some social media feed while waiting in line for a coffee? Or maybe you were just sitting at your desk, kind of idly scribbling a grocery list onto a Post-it note.
Or maybe just staring out the window of a bus, just watching the billboards pass by in your peripheral vision.
Exactly. And here is the slightly terrifying, but I think ultimately beautiful truth about whatever it was you were doing. Not a single one of those acts was neutral.
No, not one.
Every single time you scroll, every time you just stare at a blank wall, every time you doodle on a napkin, the biological software inside your head is actively rewriting itself.
Yeah, and it does not ask for your permission to do so.
Which is just wild to think about. It completely shifts how we understand, human consciousness
Yeah.
and agency.
It really is a profound paradigm shift.
Mhm.
Because we have this really deep-seated tendency to think of our brains as passive recording devices.
Like a hard drive.
Right, exactly. We treat them like hard drives that we can consciously choose to, turn on when we want to learn something for a test, and then just turn off when we want to relax and watch TV.
But that's not how it works at all.
Not even a little bit. And that's the core axiom we really have to establish right out of the gate today. Neuroplasticity, which is the brain's physical ability to reorganize itself by, forming new neural connections, that is an unconditional, continuous, and just relentless process.
It never stops.
Never. The difference between you actively focusing your attention on a complex textbook and you passively scrolling through a feed of random disconnected videos, it isn't a question of whether your brain changes.
It's just about the degree of the change.
Exactly. It's the amplitude, the depth, and the direction of that change.
And that reality, the constant rewriting, is the driving force behind our deep dive today. We're exploring this fascinating concept from the materials, focusing on what they term the Biosoftware, or, translated into English, the Biosoftware.
Right.
Our mission today is to look at 4 highly precise physiological acts. We're looking at writing, drawing, reading, and contemplation.
The big 4.
Yeah, the big 4. We're going to uncover the hidden neurophysiology behind the physical trace, the visual form, the written sign, and the act of gazing. But, before we get to the specific mechanics of, say, holding a pen or looking at a circle, we have to truly understand the rule book of this biosoftware.
Foundational rules, yeah.
Because you called neuroplasticity an unconditional process. But, how absolute is that really? Does it happen every single time?
It is entirely absolute. To fully grasp this, we kind of have to travel back to 1949.
Yeah, let's go.
There was this Canadian psychologist named Donald Hebb, and he published a book called The Organization of Behavior. In it, he coined a principle that would basically become the absolute bedrock of modern neuroscience.
Right, the famous phrase.
Yeah, neurons that fire together wire together.
Right, and it's one of those phrases that gets thrown around in self-help books and seminars all the time.
Mm-hmm.
But biologically, what is actually happening in the brain tissue when they wire together?
That's the crucial distinction to make, because it's not a metaphor, right? It's a physical, structural event. So a synapse is the microscopic gap between 2 neurons.
Okay.
When one neuron fires an electrical signal, it releases chemicals across that gap to trigger the next neuron. Hebb proposed, and modern imaging has obviously since proved this, that every single time a circuit in your brain is activated by a stimulus, the physical architecture of that synapse actually changes.
Like it physically alters its shape.
Yes. The receiving neuron builds more receptors, the sending neuron stores more neurotransmitters, the connection becomes slightly more efficient, and it actually gets physically thicker.
Wow. Like a cable being reinforced.
Exactly like that. And here is the absolute kicker when it comes to the biosoftware. Hebbian plasticity does not care, even a little bit, if you meant to activate the circuit.
It is completely indifferent to your personal goals.
Entirely indifferent. The brain doesn't have a switch that says, oh, they're just relaxing right now. Don't build any synapses here.
Right.
This was actually brilliantly proven in 1984 by Michael Merzenich and his colleagues. They were mapping the sensory-motor cortex.
And that's the strip of the brain that controls body movement and touch, right?
Yeah, exactly.
This is where we get that weird image of the homunculus, right? Like that distorted map of the human body laid across The brain tissue, where the hands and the lips are massive because they have so many nerve endings.
Precisely, the homunculus. So Mersenich found that these cortical maps are not fixed in childhood, which is what everyone previously believed.
Oh, they thought you just grew up and your brain was set.
Right, but he found they continuously reorganize themselves based entirely on repeated experience. If a specific finger is stimulated repeatedly, the area of the brain mapping that finger physically expands.
It just takes over more real estate.
It literally encroaches on the territory of the neighboring fingers. And this happens whether the stimulation is a deliberate action or just a passive, repeated touch that the subject isn't even paying attention to.
So just the exposure itself is the architect,
The exposure is everything.
which perfectly sets up one of the most famous neurological studies of all time. I know we have to talk about Eleanor Maguire's study from the year 2000, looking at the London taxi drivers.
Oh, we absolutely do, because it perfectly illustrates the sheer scale of this biosoftware rewriting process. So for context, to become a driver of one of those iconic black cabs in London, you have to pass this legendary test known simply as the knowledge.
Right, and calling it a test is almost like an understatement. It's more like a years-long hazing ritual for your spatial memory.
It is brutal. These candidates spend 3 to 4 years driving around London on mopeds with clipboards, rain or shine.
Just constantly driving.
Yeah, and they have to memorize the exact layout of roughly 25,000 streets
25,000! That is insane!
and thousands of landmarks. Plus, they have to be able to instantly recite the shortest legal route between any 2 points in the city.
So it's a monumental cognitive task.
Exactly. So Maguire and her team took these drivers and they put them into MRI machines to look at their hippocampi.
The hippocampus being that sort of seahorse-shaped structure deep in the brain that acts as the hub for memory and spatial navigation.
Right. And what they found was just astonishing. The posterior hippocampus, so the specific rear portion of the structure that deals with the spatial representation of the environment, was physically, structurally larger in the taxi drivers compared to the general
And
population.
it actually expanded.
It had expanded. It grew more gray matter.
Literally like a bicep growing after months of lifting weights at the gym.
Exactly like a muscle. But here is the crucial takeaway for our exploration of the biosoftware today. The brain didn't get bigger because the drivers sat there and said to themselves, I really want my brain to grow.
Right. They didn't will it into existence.
No, the brain grew because the daily, relentless exposure to the streets of London, the constant biological demand to navigate that specific chaotic geometry, it forced the biosoftware to update its hardware.
It just had to adapt to survive the environment.
Right. The repetition, even the exhausting, thoughtless repetition on a rainy Tuesday afternoon, physically altered their architecture.
And it goes even further than actually doing the action, doesn't it? Because the sources bring up mirror neurons, referencing work by Carr and others around 2003. And this is where the idea of passive exposure gets really, really intense.
It really does. So mirror neurons are a class of neuron that activate both when you perform an action and when you observe someone else performing that exact same action.
Wait, so if I just sit perfectly still and watch you pick up a pen and begin to write,
The exact same motor circuits in your own brain light up as if you were holding the pen yourself.
that's crazy. I literally just watched you pick up your pen to take a note a second ago, and my brain rehearsed the action.
Without your permission, your brain simulated the physical weight of the pen, the motor command to the fingers, the entire sequence of the movement. Just by observing it, your biosoftware ran a full simulation.
So if I could just throw an analogy out here to try and make sense of this.
Sure, go for it.
It kind of feels like the human brain is a smartphone that is constantly downloading background updates over whatever Wi-Fi network it happens to walk past.
Oh, that's good.
And it never asks for your password, it never asks for Face ID, it never asks for permission. It just silently installs whatever data it connects to in the environment.
That is an incredibly accurate analogy, but I think we have to ask why the smartphone is designed that way in the first place.
Okay, why?
Because the brain is not just a sponge soaking up water for the fun of it. The brain is a predictive engine. Its primary evolutionary job is to keep you alive tomorrow by predicting what you will encounter based on what you experience today.
So it's always looking ahead.
Always. It constantly adjusts its sensory filters and its physical structural networks based on whatever it is exposed to most frequently.
Because if it's exposed to it frequently, It just logically assumes it will need to process it again to survive in the future.
Precisely. So if you casually read a billboard or you mindlessly scroll through a feed of erratic, flashing videos while waiting for a train, you might consciously categorize that time as downtime.
You think you're just resting your brain.
Right. You think you are resting.
Yeah.
But biologically, the predictive engine is working at full capacity. It is actively reshaping your neural pathways to make you better at processing erratic, disjointed video feeds.
Oh, wow.
It's an active biological event.
That is a staggering way to frame it. It really makes you think twice about pulling out your phone in line at the grocery store.
It really does.
So, okay, if passive exposure changes us whether we like it or not, what happens when we intentionally engage our bodies? Let's move from those background downloads to active keystrokes.
Let's just do it.
Let's talk about the first of our 4 physiological acts, writing, and specifically writing by hand, because I feel like in the modern digital age, we've kind of reduced writing to mere data entry.
We absolutely have.
It's just this logistical task of getting a thought from my brain onto a digital document as fast as humanly possible. But physiologically, the act of using a pen is ancient and incredibly complex, isn't it?
I mean, the word complex almost undersells what is happening. Writing by hand is what neuroscientists call a total act.
Total act.
Yeah, it isn't just a localized function. It recruits this massive distributed network across the entire brain simultaneously.
Walk us through it. What happens when I just write a word?
Okay, think about the biomechanics. When you pick up a pen to write a single word, first you engage the primary motor cortex to orchestrate the really fine, microscopic coordination of the muscles in your fingers and your hand.
Just gripping the pen with the right amount of pressure. So it doesn't slip, but, not so hard that you snap it in half.
Right. Then you engage the cerebellum to sequence the precise timing of the strokes, like the curve of an A, the cross of a T.
Read it.
The basal ganglia step in to automate the patterns of the letters you've learned since childhood, so you don't have to consciously remember exactly how to draw an E every single time.
And that's entirely just the movement part. That's just the physical machinery.
Exactly, that's just the hardware moving. Simultaneous to all that motor output, your brain is running the linguistic software.
Okay.
Broca's area is firing to produce the language and syntax. Wernicke's area is processing the semantic meaning of the concept you are trying to actually articulate.
Wow.
And your visual cortex is on high alert, providing continuous real-time feedback on the trace of ink you are leaving on the paper, adjusting the motor commands if you drift off the line.
It's an absolute symphony of neurology, and it's all happening just to write down, like, buy more milk on a Post-it note.
Yeah, it's incredible.
But this immense neurological complexity brings up a massive debate highlighted in our material. The contrast between handwriting and typing.
Yes, the typing debate.
Because we have 2 major studies referenced here. Mangan and Villay from 2010, and the famous Mueller and Oppenheimer study from 2014, which was published in Psychological Science.
Right.
And honestly, the results of these studies are a huge wake-up call for anyone listening to this who takes notes on a laptop.
They really are a wake-up call. Mueller and Oppenheimer set up this fascinating experiment. They had students watch TED Talks and university lectures, and they divided them into 2 groups.
Okay.
One group took notes by hand with a pen and paper, and the other group took notes by typing on laptops. Afterwards, they tested the students on both factual recall and conceptual understanding of the material.
And the results?
The students who took notes by hand comprehended and retained the information significantly better than those who typed.
But wait, here's where I have to push back just a little bit.
Okay, push back.
Isn't that just kind of romanticizing inefficiency? Because if I am in a high-stakes corporate meeting or a really dense university lecture, and I am handwriting my notes, I am going to miss half of what the speaker says because I literally cannot move my hand fast enough.
That's a con argument, yeah.
Right. The laptop users get way more data down. How is losing half the data a biological advantage?
That is exactly the illusion of the digital age. We are confusing data capture with cognitive integration.
Ooh, say that again.
We confuse capturing data with actually integrating knowledge. You are absolutely right that the typists captured far more words. In fact, Mueller and Oppenheimer found that the laptop users often transcribed the lectures almost verbatim.
They were just word for word dictating it.
Right, they were fast. But they acted like human transcribers, not learners.
So the information just went in the ear and straight out the fingers.
Exactly. Because typing is so fast and so uniform, it requires very little cognitive load. You don't have to think about the shape of the letters, you just press identical plastic squares over and over.
Right, an A feels the same as an S.
The information enters the system, bypasses the deeper processing centers entirely, and is projected onto the screen without ever truly modifying the internal neural networks. But handwriting, as you pointed out, is inherently inefficient. It is slow.
Very slow.
And that slowness forces a cognitive bottleneck
A bottleneck. Okay, explain that.
because you physically cannot write fast enough to capture every single word the speaker is saying. Your brain is forced into a state of active, urgent conceptual processing.
Mm.
You have to listen to a whole paragraph, instantly distill its core meaning, discard all the fluff, reformulate the concept into your own words, and then command your hand to write that synthesized summary down.
Okay, that makes total sense.
That deep cognitive processing, that active distillation, is what modifies the biosoftware.
Ah, I see. So the laptop is kind of like taking a photograph of a landscape.
Oh.
You capture every single detail instantly in high definition, but you don't really have to look at it. You don't have to understand it.
Right.
But handwriting is like painting that landscape. You have to study the lighting, you have to analyze the shapes, mix the colors, and physically recreate it on the canvas. It takes 10 times as long, and it won't be a perfect one-to-one reproduction, but by the end of the process, you know that landscape intimately.
I love that analogy. You are building an internal model of the landscape rather than just, storing a file on an external hard drive.
Yeah.
And there is a purely physical component to this too, which Mangan and Vallée really emphasized in their 2010 work. Handwriting activates proprioceptive circuits.
For proprioception, our body's ability to sense its own movement, action, and location in space.
Right. It's how you can touch your nose with your eyes closed. When you write by hand, you feel the physical sensory reality of the act. You feel the temperature and weight of the pen in your grip.
The actual physical sensation.
Yes, you feel the downward pressure of your hand resting on the wooden desk. You feel the micro vibrations, the friction, and the resistance of the paper against the nib of the pen as you push it across the page.
And you get absolutely none of that from tapping a smooth glass iPad screen or pressing identical plastic keys where, like we said, an A feels exactly the same as a Z.
Precisely. And here is the neurological magic of it all. Those proprioceptive circuits, the sensory pathways mapping the physical friction of the trace, they are directly biologically wired to the episodic memory centers in the brain.
Wait, really? So
Yeah.
because my hand remembers the physical struggle and the sensory friction of writing a specific sentence, my brain anchors the abstract concept of that sentence to a physical memory.
Yes. The physical trace left on the paper corresponds to an actual neurological trace left in your brain.
That's incredible.
The memory of the concept is anchored by the physical sensory reality of the act of writing. So when you try to recall the information later during a test or maybe during a big presentation, your brain actually retrieves the motor memory of writing it to help access the semantic memory of what it means.
That is such a huge practical takeaway for you listening right now. If you really need to remember something, whether it's an important project brief, a concept for an exam, or even just a really profound thought you had while walking with Threet, drop the keyboard. Pick up a pen.
Pick up the pen.
The inefficiency is the point. The friction is the feature.
It really is. And, if we connect this to the deeper history of human neurology, writing is actually a very recent development for our species.
Oh, sure. In evolutionary terms, it's brand new.
The earliest alphabets have only been around for a few thousand years. To truly understand the root of the physical trace and how our biosoftware became wired to respond to forms in the first place, we have to look much further back in our evolutionary timeline.
Where are we going?
We have to look at drawing.
Ah. So we've seen how pushing information out of our bodies via our hands acts like a cognitive anchor. But writing uses alphabets, these highly abstract, agreed-upon symbols. What happens when we strip away the alphabet entirely?
Then we get down to the primal layer.
Right. That brings us to drawing and geometry, the form before the word. Because when we look at human history, we have the cave paintings at Lascaux in France, which are about 37,000 years old.
Right.
We have the El Castillo cave in Spain at 40,000 years old. And we have the Blombos caves in South Africa, where archaeologists found these cross-hatch geometric patterns drawn on ochre that date back an astonishing 75,000 years.
It's mind-boggling to think about.
Long before we had a phonetic alphabet to spell out a word, the human brain was already perfectly equipped to produce and receive complex visual forms.
Drawing is physiologically ancient. It is much older than writing, and therefore its roots are much more deeply embedded in our foundational primitive neural architecture.
We've been doing it way longer.
Way longer, we evolved as hypersensitive pattern detectors. Our survival literally depended on our ability to look at a chaotic visual environment like a dense jungle or a sprawling savanna and instantly recognize shapes that meant food, water, or danger.
We had to spot the tiger in the grass.
Exactly. And what's crucial to understand here is that different types of geometry speak to completely different parts of our brain.
Okay, let's break that down
Yeah.
because this absolutely blew my mind when I read it in the materials. What exactly happens in the biosoftware when we look at different shapes?
Well, let's start with angular shapes. Think of triangles, squares, sharp intersections, jagged lines.
Okay.
When your visual cortex perceives these sharp angles, it primarily routes that information to the prefrontal cortex, which is the highly analytical, problem-solving, alert part of the brain.
But why? Why do angles make us analytical?
Think about what sharp angles represent in the natural world. In nature, living, organic things are rarely perfectly straight or sharply angled.
True. Trees and animals are curvy.
Right. Sharp angles usually denote broken things, a
Hmm.
snapped branch, a jagged rock, a cliff edge, or, the teeth or claws of a predator.
Wow.
They represent boundaries, edges, and potential hazards. So when you see angular geometry, it creates a microtension in your nervous system. It induces a state of alertness, calculation, and analysis.
So a room full of sharp, right-angled modern furniture is literally telling my brain to stay on guard.
Subconsciously, yes, your brain is scanning those edges. On the other hand, we have organic shapes, circles, spirals, flowing curves, undulating lines.
And what do those do?
When you perceive these, they solicit the much older, archaic thalamic system.
And what does the thalamic system associate those curves with?
It associates them with the flow of the natural world. These shapes mimic the curves of living things, the rounded shapes of fruits, the undulating movement of a river, the cycle of the sun and moon, the shape of the human body itself.
Things that are safe.
Exactly. They don't require urgent analytical decoding. They create a sense of anchoring, of physiological safety, and rhythmic continuity.
This ties perfectly into a concept explored in our materials called ontopoiesis.
Yes, ontopoiesis.
I actually had to look this term up. It essentially translates to the spontaneous production of meaning when faced with a complex form.
Right, because the human brain simply cannot tolerate a vacuum of meaning. It is biologically painful for us to look at a pattern and not know what it means.
We hate randomness.
We despise it. When we see a complex shape, our brain irresistibly, automatically attempts to decode it, to project a narrative onto it. And the sources use a fascinating sociological example to illustrate this.
Yes, the crop circles.
The crop circles.
Oh, this is great. Because the debate over crop circles usually centers on who made them, whether they are made by local artists with wooden planks and ropes sneaking into a field at midnight, or, extraterrestrials.
Right, the usual suspects.
But the real phenomenon isn't the circles themselves, is it?
No, the true phenomenon is the human neurological reaction to them. Imagine the visual contrast. You have this massive, chaotic, highly organic canvas of a wheat field blowing in the wind.
Just total natural randomness.
Right, and suddenly, injected right into the middle of it, is a massive, mathematically perfect, hyper-complex geometric mandala.
It's jarring.
When the human brain sees that extreme contrast, the biosoftware immediately kicks into ontopoiesis.
It goes into overdrive trying to explain it.
Exactly. We immediately generate massive meaning. We create entire subcultures of ufology, theories about mystical earth energies, ley lines, complex alien communications.
You just can't accept that it's just some guys with boards.
We can't. The sheer mathematical perfection of the shapes bypasses our modern, skeptical prefrontal filters and speaks directly to this ancient pattern-seeking nervous system. We must make it mean something profound because the geometry is so commanding.
Okay, I want to bring this ancient geometry back down to a very common, everyday modern behavior.
Okay.
Think about being stuck on a long, agonizingly boring phone call or sitting at a tedious corporate meeting. People doodle.
They absolutely do.
They grab a pen and the margins of their notebook and they draw, but they don't usually draw realistic portraits, right? They often doodle repetitive geometric shapes, spirals, interlocking boxes, concentric circles, waves. Are we subconsciously trying to regulate our own nervous systems by drawing these specific shapes? Like, is doodling essentially just a visual fidget spinner?
That is an excellent way to conceptualize it. Let's expand on that fidget spinner analogy for a second. Why does a fidget spinner work?
Because it gives you something to do with your hands?
Exactly. It works because it offloads restless, excess kinetic energy through the hands. It engages the motor cortex just enough so that the rest of the brain can focus on the task at hand. Doodling does the exact same thing, but for visual and spatial anxiety.
How does it do that, though?
The act of drawing links the primary motor cortex, so the movement of your hand, with the visual cortex, watching the line appear, and the thalamic system. When you draw repetitive organic shapes like continuous spirals or figure eights, you are physically tying your biosoftware to a rhythmic, predictable, soothing feedback loop. If the meaning is causing you stress, your brain is likely in a high-frequency, jagged beta wave state. Drawing those curves manually forces the brain to shift out of that stressed state and induces a calming, rhythmic wave pattern.
It's basically an instinctual biological attempt to recalibrate your own biosoftware.
Using the oldest language we possess, geometry.
That is wildly fascinating. It really makes me look at the artwork I choose to hang on my walls or the literal shape of my desk totally differently. Are we surrounding ourselves with tension-inducing angles or calming organic curves? We are constantly being modulated by the ambient geometry of our environment.
Constantly.
So we spend a lot of time talking about output, the physical acts of pushing information out of our bodies, down our arms, through a pen, and onto a physical medium, whether that's writing words or drawing spirals.
Right.
We are projecting meaning.
Output.
But what happens when we reverse the flow? What happens when we aren't creating the trace, but just absorbing it? Let's pivot to input. Let's talk about reading and what our materials call the regimes of attention.
Ah, yes. The regimes of attention.
Because reading isn't just about absorbing facts. As we've established with our biosoftware axiom, we're talking about fundamentally altering the physical parameters of our brain.
And here we have to draw a stark, unyielding line between two fundamentally different diets of consumption. The materials define these as the contemplative diet versus the algorithmic diet.
Let's start with the contemplative diet, because that's the one humans have been doing the longest.
Yeah.
This is sustained attention on a single object, reading a long-form book, for example.
Right. When you engage in contemplative reading, let's say you sit down with a dense 400-page novel or a long-form philosophical essay, you are locking your attention onto one linear narrative, one consistent voice, or one progressive argument for an extended period of time.
You aren't bouncing around.
No. You are deliberately blocking out competing stimuli. Physiologically, longitudinal studies show that this practice actually structurally thickens the insular cortex and the prefrontal cortex.
It literally adds physical density to those areas.
Yes. Through that Hebbian plasticity we discussed earlier, it reinforces the neural cabling in the areas of the brain responsible for deep thought, empathy, complex problem solving, and executive control.
That's amazing.
Furthermore, this state of sustained, single-pointed attention has been shown to reduce systemic inflammation in the body and vastly improve emotional regulation.
So sitting down and reading a physical book for an hour is quite literally an anti-inflammatory medication for the brain.
It acts as a powerful bioregulator, yes. It brings the system into coherence. But then, we must contrast that with the algorithmic diet.
Here we go.
And this is the modern digital reality that almost all of us live in. This diet is defined by the rapid alternation of highly heterogeneous, emotionally disparate content.
Right, like you open a social media app, the first post is a funny meme, the next post is a news headline about a devastating war.
Completely different emotional tone.
Yeah, and then the next post is a targeted ad for shoes, the next is an influencer doing a dance. It's wildly disjointed.
And it is all driven by variable reward schedules, which are engineered by algorithms designed specifically to maximize engagement.
The slot machine effect.
Exactly. Pull the lever, see what you get. This algorithmic diet is catastrophic for the biosoftware when consumed constantly. It reduces our capacity for sustained attention, it fragments our working memory, and it drastically increases attentional impulsivity.
But why? What is actually happening in the brain when we swipe from the war headline to the dancing influencer?
Every single time you shift your attention to a new, disparate piece of content, your brain has to completely reorient its emotional and cognitive posture.
It has to reboot.
It has to load a whole new context. And this rapid context switching violently exhausts the prefrontal cortex's glucose reserves.
Glucose being the physical sugar, the fuel the brain uses to operate.
Yes, you are literally burning through the brain's finite daily fuel supply just to switch context every 3 seconds. You aren't doing deep thinking, you are just paying the overhead cost of loading new files over and over again until the system is depleted.
This brings us to a study that genuinely terrified me. The 2018 meta-analysis by Adrian Ward, which is sometimes referenced alongside Wilmer's work on attention.
Right, the smartphone study.
They ran experiments on cognitive capacity, and they found that just having your smartphone sitting on your desk, even if it is turned completely off and face down, significantly reduces your capacity for sustained attention and fluid intelligence.
Which raises a profoundly important question about our environment. Why does an inanimate, powered-down object sitting silently on a desk drain our cognition?
Right. If it's off, it's just a slab of glass and aluminum. Why does it hurt my brain?
Because your biosoftware has been heavily conditioned to view that specific object as a portal to infinite social, survival, and novelty information.
The brain knows what it is.
The brain knows exactly what that object represents. So when you are trying to read a report, but the phone is in your peripheral vision, part of your brain's processing power, part of your cognitive bandwidth, has to be actively spent suppressing the urge to reach out and check the phone.
Oh, wow. It takes actual metabolic energy to ignore it.
Exactly. It's like trying to work while someone is standing next to you holding a plate of your favorite warm cookies.
You're smelling them the whole time.
Right. Even if you don't eat them, you are using energy to resist them. The phone colonizes your perceptive space and drains your glucose just by existing in your field of view.
That is wild. The sources call this the attentional saturation protocol.
Oh.
And it's such a striking phrase. We curate our nutritional diet so carefully. We check macros, we avoid processed sugar, we buy organic, but we almost never curate our attentional diet.
We let anything in.
We really do. You mentioned glucose exhaustion earlier. Let's really dig into this. I always assumed a notification just, distracted my train of thought, maybe annoyed me a little. But it sounds like you're saying there's an actual chemical tax I have to pay every time my phone buzzes.
There is a massive tax.
Walk us through the biological mechanism of a single notification. Say I am working deeply on writing an essay, and my phone buzzes on the desk. What actually happens to my biosoftware?
Well, to understand the tax, you have to understand the cost of operation. The brain is an incredibly energy-hungry organ. It consumes about 20% of the body's total metabolic energy, despite making up only about 2% of its physical weight.
It's an engine.
Right. When you are deeply focused on writing that essay, your brain waves are likely in a stable, synchronized, coherent state. Your neural networks are humming in a unified rhythm.
The zone.
The zone, exactly. Then the phone buzzes. The sudden sound and vibration trigger the locus coeruleus.
What is that?
It's a small nucleus in the brainstem that acts as the brain's panic button or alarm center. When it detects that sudden stimulus, it fires a spike of noradrenaline across your cortex.
And more adrenaline.
It's a neurotransmitter related to adrenaline. It is designed for fight or flight responses. Your attention is violently, chemically yanked away from your essay and directed toward the threat or novelty, the phone.
So my brain literally treats the buzz like a twig snapping in the dark woods.
Yes. Your coherent brainwave state shatters. You look at the notification. Let's say it's just a promotional email. You dismiss it and go back to your essay. But you can't just instantly resume deep focus.
Because the essay has been wiped from the whiteboard of my working memory.
Exactly. Research into interruption science indicates that after a forced context switch like that, it can take up to 23 minutes for the brain to return to the previous state of deep, synchronized focus.
23 minutes from a 1-second buzz.
Yes, because you have to slowly rebuild the entire cognitive architecture you were holding in your working memory. You have to remember the premise of the paragraph, the tone you were using, the specific vocabulary you were queuing up.
It's like rebuilding a house of cards.
It is. And the modern digital world forces the brain into this state constantly. We call it chronic beta wave hyperactivation. We are constantly in a state of high alert processing, flooded with noradrenaline, which strips away our ability to access the restorative, deeper alpha and theta brainwave states.
We are actively hijacking our own dopaminergic systems, trading long-term structural integrity for short-term hollow dopamine hits.
It's exactly what we're doing.
That's a stark reality check. If you're listening to this on a commute or sitting at your desk right now, just look around you. Look at how many screens, tabs, and devices are secretly depleting your cognitive battery and chemically taxing your biosoftware at this exact moment.
It's probably more than you think.
Way more. Which leads us perfectly into the next major concept. If the algorithmic world is an attentional saturation protocol forcing us into this state of chronic beta wave exhaustion, what is the antidote?
We need an antidote.
How do we use the final of our 4-acts contemplation to heal our neural pathways and recalibrate the biosoftware?
If the poison is saturation, the antidote is sensory reduction.
Okay.
Sensory reduction is a technology of consciousness that humans have utilized for millennia across countless cultures and traditions, long before we had fMRI machines to biologically prove that it worked.
Right.
When external input drops significantly, the brain's predictive engine, which, as we discussed, is always furiously trying to guess what happens next, suddenly encounters a void.
The materials bring up the most incredible architectural example of this. The Karasansui, the Japanese dry Zen garden.
Yes, the Zen garden.
I have to admit, I always thought of Zen gardens as just
Yeah.
very minimalist, aesthetically pleasing landscaping, like just a
Yeah.
nice place to sit.
Hmm.
But our sources describe the Zen garden as a literal biophysical regulator,
Hmm.
a piece of technology.
It is a profound piece of neurological engineering. It is literally designed to hack the biosoftware. Let's break down the mechanics of how it works on the human body.
Please do.
The Karasansui utilizes vast amounts of empty space. This is a design concept known in Japanese aesthetics as ma.
Yes.
Yes. This intentional emptiness drastically reduces the cognitive and sensory load on the brain. There are no flashy colors, no complex moving parts, no dense information to decode.
It's the ultimate anti-algorithmic environment.
Precisely. When you sit and gaze at this empty space, this environmental desaturation triggers the vagus nerve.
The vagus nerve. We hear a lot about this in wellness circles.
The vagus nerve is the superhighway of the parasympathetic nervous system, running from your brainstem down through your torso. When it's triggered by the safety and stillness of the garden, the vagus nerve signals the hypothalamus in your brain to halt the production of CRH,
What's CRH?
corticotropin-releasing hormone.
And CRH is the first domino that starts the stress cascade, right?
Exactly. It's the hormone that tells the body it's under attack. Without CRH, the pituitary gland stops making ACTH, and consequently, your adrenal glands stop pumping out cortisol, the primary stress hormone.
Wow.
Within minutes of gazing at the empty space, your systemic stress levels plummet. But the genius of the Zen garden isn't just the empty space, it's the raked gravel.
The meticulous lines they draw in the sand around the rocks.
Yes. Those precise, parallel geometric lines raked into the stone act as a visual metamaterial. When we are in a normal, cluttered environment, our eyes are constantly darting around in rapid, involuntary movements called ocular saccades.
We are scanning for threats or novelties.
We're acting like the hyper-alert pattern detectors we evolved to be.
Right. But when you look at the parallel lines of the raked gravel, there is nothing to frantically scan for. The lines are continuous and predictable. They physically stabilize those ocular saccades. They guide the eyes into a state of smooth pursuit or steady fixation.
Because the visual geometry is doing the work for you. It's
Totally.
organizing your vision.
Exactly. And as the physical movement of the eyes stabilizes, the visual cortex downregulates its activity. This reduction in visual processing induces the brain to produce alpha waves, which oscillate right around 8 to 12 hertz.
And alpha waves are good.
Alpha waves are the signature frequency of calm vigilance. You are completely awake, completely present, but the physiological tension is entirely gone. The garden has manually shifted your brainwaves. Okay, so that is visual contemplation. Staring at an external object to regulate the internal state. But we also have to dive deeply into contemplative somatic practices. Things like conscious dance, tai chi, or mudras. For those who don't know, mudras are precise hand and finger postures used in yoga and meditation traditions.
Somatic anchoring, using the body's physical position to change the mind, is just as powerful as visual contemplation. Let's translate some of the more academic language around this from the materials.
Help us out.
When you do Tai Chi or engage in conscious dance, your body isn't just playing back a pre-recorded tape of rote movements. You are actively figuring out your physical place in the world in real time. You are creating new neural maps on the fly, coordinating breath, balance, and spatial awareness.
It's active integration.
Yes. But let's look at mudras, because they are incredibly precise. You might think holding your thumb and index finger in a specific loop resting on your knee is purely symbolic, like a religious or cultural artifact. But neurobiologically, our hands and fingers are the most densely packed areas of sensory nerve endings in the entire body.
Going back to that homunculus map again, our hands take up a massive amount of brain real estate.
Exactly. So when you hold a precise geometric posture with your hands, pressing specific nerve endings against each other with a specific amount of pressure, you are creating a localized, highly controlled biofeedback loop.
Our materials mention that these specific postures mathematically alter the kinetic clearance of cortisol from the bloodstream.
They do.
I need to stop you there. Bending my fingers in a specific loop changes the chemical clearance rate of stress hormones in my blood. That sounds almost esoteric. What is the actual biological mechanism
I
there?
know it sounds like magic until you look at the neuroanatomy. Because the fingertips are so densely innervated, applying steady, mindful pressure stimulates the terminal ends of pathways that feed back into the vagus nerve.
Ah, the vagus nerve again.
Just like the Zen garden visually triggered the vagus nerve, the mudra physically triggers it. The vagus nerve increases parasympathetic tone, which dilates blood vessels, slows the heart rate, and improves liver function.
And the liver clears the cortisol.
Exactly. The liver is responsible for metabolizing and clearing cortisol from the blood. By shifting the autonomic state so profoundly, you are literally accelerating the biological machinery that filters out stress chemistry.
That is unbelievable. And this connects back to something truly fascinating from our exploration.
Mm-hmm.
We often picture the human brain as this gray, static, rubbery lump. That's how it looks in textbooks or jars of formaldehyde. But the living brain isn't gray at all, is it?
No, not at all. The living, breathing brain inside your skull right now is a pulsing, vivid salmon pink matrix.
Salmon pink.
It is incredibly dense with blood vessels, completely engorged with fluid floating in cerebrospinal fluid, and it acts as a dynamic, multispectral electromagnetic antenna. Our brainwaves are not just metaphors, they are actual, measurable bioelectromagnetic oscillations.
A pulsing pink antenna. That is quite the image.
It's reality. And deep contemplation, absolute silence, and these focused somatic practices physically alter the frequency of that antenna. They bring the brain down from the frantic, jagged, high-frequency beta waves of the digital algorithmic world down through the calm of alpha and ultimately down into theta and delta states.
And delta is where the real biological magic happens, right?
Yeah. Delta waves, the slowest and deepest brain waves, are where cellular regeneration occurs. It's where the glymphatic system operates.
The brain's dishwasher.
Exactly. I love that term. During these deep states, the actual glial cells in the brain shrink slightly.
They shrink.
Yeah, they shrink. This creates space between the neurons, allowing cerebrospinal fluid to rush through the tissue, physically washing away toxic metabolic waste products that have built up during the day, specifically proteins like amyloid beta, which are implicated in Alzheimer's disease.
Wow. So it literally washes the brain.
It does. If you don't access these deep, slow-wave states, the waste builds up, the antenna becomes clogged with static.
That is terrifying.
Furthermore, there was a fascinating study done back in 2013 by Imke Churst and her colleagues. They were studying the effects of ambient noise on mice, but they included silence as a control group.
Just normal silence.
Right. What they discovered shocked them. Just 2 hours of complete, unadulterated silence a day induced actual neurogenesis, the birth of brand new neurons in the hippocampus.
Silence literally grew new brain cells.
Yes. The absence of input forced the brain to build new capacity.
So is contemplation just hitting the restart button on this pink antenna to clear the static?
It's much more than a simple restart. It is active, vital maintenance. It is the necessary biological process of clearing the informational friction that builds up in the synapses. Without it, the hardware physically degrades.
That is tangible, indisputable proof for everyone listening that taking 10 minutes to sit in absolute silence or doing a mindful movement practice or just staring at a blank wall is not wasted time.
It's not a luxury.
Right. It is not doing nothing. It is a vital biological imperative for brain maintenance. Which brings us to a profound pivot in our exploration today.
Yes. Let's talk about the exceptions.
Because while everything we've talked about so far applies to the general architecture of the human brain, for some individuals, this antenna is tuned to a fundamentally different frequency. And for them, everything we just talked about is magnified.
Right. We need to explore how the biosoftware operates in neurodivergent profiles.
Okay.
We are looking specifically at autism spectrum profiles like Asperger's and bipolar profiles, as well as brains that have experienced severe early trauma. In these systems, the acts of writing, drawing, reading, and contemplation aren't just, clever optimization strategies for a better workday.
It's not a productivity hack.
No. They are absolute, non-negotiable lifelines for biological and psychic survival.
The mechanics of this are explained so clearly in the materials when you look at sensory filtering. In a neurotypical brain, the sensory filters in the thalamus automatically block out irrelevant background noise. The neurotypical brain ignores the hum of the refrigerator, the microscopic flickering of a fluorescent light above the desk, the scratchy texture of a shirt tag, the complex smells of a crowded room. But in a hypervigilant or neurodivergent brain, those filters are highly permeable. They are porous.
They absorb a massive, unfiltered tidal wave of stimuli simultaneously. The antenna picks up every single frequency on the dial at maximum volume.
And this is where the biochemistry becomes so critical. For a brain with its hyperpermeable profile, sensory overload isn't just an annoyance. It isn't just feeling, quote-unquote, distracted. It triggers an actual neurochemical crisis, doesn't it?
It does. It absolutely does. When the neurodivergent system is overwhelmed by stimuli, say a chaotic open plan office or a really loud supermarket, it triggers a massive cascade of glutamate.
Glutamate.
Glutamate is the brain's primary excitatory neurotransmitter. It essentially hits the gas pedal of the central nervous system, demanding rapid firing and intense processing.
But what happens to the brakes?
The brakes fail. The primary inhibitory neurotransmitter, GABA gamma aminobutyric acid, which is supposed to calm the system down and counteract the glutamate, gets rapidly depleted.
Oh, no.
The result is an uncontrolled state of hyperexcitability. The neurons are firing so fast and so hard that in severe cases of sensory overload, neurologists can observe an actual measurable thermal heating of the brain tissue due to the extreme metabolic overdrive.
The brain is literally running too hot, like a computer processor without a cooling fan.
That is exactly what is happening.
That is terrifying, but it perfectly explains why the acts of writing and drawing become so vital for these individuals. It's not just creative expression, it's a mechanism of survival. If you are caught in a glutamate storm, where the world is a chaotic flood of overwhelming, terrifying sensory data, putting a pen to paper and drawing a clean, continuous line or writing a highly structured sentence acts as a physical tether.
It creates a localized zone of coherence. By gripping the pen and forcing the hand to move in a precise intended geometry, you are manually engaging the prefrontal cortex and the motor systems.
You're forcing it to slow down.
You are forcing the chaotic beta and gamma waves to synchronize with the slow, deliberate motor action of the hand. It is a way to manually override the glutamate cascade. Writing preserves the reality and the integrity of the subject against the fragmentation of the environment.
But there's a really profound sociological point here about how modern society views and values these different types of biosoftware. Throughout history, different societies implicitly value different neurological traits.
They really do.
Industrial societies, the era of the factory, valued endurance, rote repetition, and strict obedience. The ideal brain was one that could stand at an assembly line for 12 hours and not go insane. But today, modern digital societies value hyperproductivity, rapid context switching, and extreme cognitive flexibility.
And neither of those environments is hospitable to a hypersensitive neurodivergent antenna.
Not at all.
The modern digital workplace is essentially designed to trigger a glutamate storm. These brains require highly structured environments to prevent the biosoftware from crashing. They need meticulous, intentional regulation of light, sound, nutrition, and even the predictability of social relationships.
Routine is medicine.
It is. For a neurodivergent profile, an unexpected loud noise or a socially ambiguous passive-aggressive interaction isn't just a minor blip to brush off. It is a massive energetic cost to their system that has to be metabolically paid for.
It makes you reflect on the sheer resilience of the human brain, the brain's desperate attempt to find meaning and order. In extreme cases of trauma, this can result in coping mechanisms like dissociation, pulling away from reality, or apophenia, which is seeing connections and patterns that aren't really there.
Right.
When you look at it through this biological lens, you realize it's actually a feature, not a bug. It's a brilliant survival mechanism. The brain is trying to map a chaotic, threatening world to keep the organism alive at all costs.
That is a vital perspective to hold. A neurodivergent brain or a traumatized brain isn't broken. It is exquisitely adapting to the parameters it has been given, or the genetic parameters it possesses biologically.
It's doing its job perfectly.
Exactly. If you have an antenna that picks up every single signal, you have to build walls. You have to create rigid daily routines, and you have to use physical tools like writing, geometry, and absolute silence just to filter the signal from the noise. You curate your environment because your biology demands it.
It really fosters deep empathy. It makes you understand how profoundly different minds process the exact same world. And honestly, it encourages all of us, neurotypical or neurodivergent, to consider what kind of sensory environment we are forcing our own brains to operate within every single day. Are we living in a way that supports the health of our biosoftware, or are we constantly forcing it into a state of inflammatory algorithmic overdrive?
That's the million-dollar question.
Okay, we have covered an incredible amount of ground today. We have zoomed in on the microscopic synaptic cleft, and zoomed out to 75,000-year-old caves in South Africa. Let's summarize the journey of this deep dive.
Let's do a recap.
We started with the foundational axiom. Your brain, your biosoftware, is constantly, relentlessly being rewritten by passive exposure. Intention is not required for plasticity. The background downloads are always running.
Always running.
Then we looked at output. We realized that handwriting isn't just a slower version of typing. It is a full-brain, physical act where the proprioceptive friction of the pen actually deepens memory and forces conceptual understanding through a cognitive bottleneck.
Then we stepped back to drawing and geometry.
Right. Realizing that sharp angular shapes create analytical tension and alert the prefrontal cortex, while organic curves speak an ancient calming language to our archaic thalamic system.
And then we explored input.
We saw how the algorithmic diet of digital reading fragments our attention, drains our glucose, and hijacks the locus coeruleus, while contemplative, long-form reading physically thickens the brain's gray matter.
And we discovered that contemplation is a biological imperative.
Whether through the empty mab of a Zen garden, lowering cortisol via the vagus nerve, or the precise posture of a mudra accelerating chemical clearance, it shrinks glial cells and washes away metabolic waste.
And finally, we saw how, for neurodivergent and traumatized brains, these acts of writing, drawing, and silence aren't just helpful life hacks.
They are critical biological tethers for regulating a hypersensitive antenna in a world that is far too loud and chaotic.
It all comes back to that central truth, doesn't it? The brain is a dynamic, living, pulsing interface. It is shaped by what it touches, what it sees, and what it dwells upon.
Which brings us back to exactly where we started. I asked you to remember those 3 minutes before you hit play on this audio.
Think about the biological reality of this past hour. Your brain's physical architecture is measurably different right now than it was 60 minutes ago when you started listening to us.
It really is.
By simply focusing your sustained attention on this deep dive, by imagining the homunculus, the Zen garden, and the pulsing pink antenna, you have physically altered the synaptic connections in your cortex. Your biosoftware has just been updated.
But I want to leave you with one final, slightly unnerving thought to chew on.
Oh boy.
We've spent this entire hour talking about human biosoftware and how it interacts with the physical world, pens, paper, gardens, and even smartphones held in our hands. But we are rapidly approaching an era where we are connecting our brains to literal software.
Neural links.
Yeah. Through neural links, brain-computer interfaces, augmented reality, and AI, the boundary between the physical world rewriting us and the digital world rewriting us directly is going to completely vanish.
That is a wild thought.
If passive exposure to a billboard on a bus changes the physical structure of your brain, what happens when that algorithm feed is projected directly onto your optic nerve or wired straight into your motor cortex? The biosoftware will adapt because it has to, but what shape will it take? Think about that next time you pick up your phone.